Hello YouTube and welcome to another network tutorial. So today we'll be talking about the Cisco ASA Firewall packet tracer for network troubleshooting. So are you ready? Let's get started. So as you may know, one of the most useful troubleshooting features of the Cisco ASA firewalls is the use of the packet tracer command. So this command is used to trace and simulate how a packet will traverse through the ASA appliance. So in order to identify possible problems, like for example a packet has been blocked or dropped. Okay. So the packet tracing features was actually introduced back on the iOS version 7.2. but it's still available till the newer actually 9.x ASA images. Okay, so with the help of this actually command, you can capture detailed packet information traversing the firewall for analysis and for troubleshooting connectivity. Okay, so in this video I will show you two practical examples. First of all, using just the command line, and second, using the GUI or the ASDM for the Cisco ASA. Okay, so the general actually syntax of this command is the packet tracer input. Then we have to provide actually the source or the ingress interface from which the simulated packet will start. Then we have to specify the protocol, so the protocol can be either TCP, UDP or ECMP. Okay, then we have to provide the source address, so the source IP address of the packet, and also the source port of the packet. So for the source port, actually we use something above the 1024. Okay, then we have to provide the destination address of the packet, the destination port, and also we can add the detailed keyword which provide detailed tracing output information. Okay, so we will see that in a very practical actually example, that actually the packet will see the packet that passed through all the steps or all the evaluation steps and enforcement that firewall applies, such as root, lookup, access control list, NAT, protocol, inspection, and etc. And at the end we'll see if the packet is allowed or blocked or dropped or something like that. So let's begin by actually providing simple example. So here I'm on the privilege mode, so I will use the command actually packet tracer. So as I told you, the first keyword is input. So here we have to provide actually the interface that the packet will start from. So here let's say that for example I will simulate a packet that is going from the inside to the outside. Okay, so our ingress interface will be in this case inside. Okay, then I have to provide, as I told you, the protocol. So let's see for example that I want just to query the Google DNS. So DNS use UDP and not TCP. Okay, and here we provide actually the source address. So the source address will be an internal host on my inside network. So here I'll provide the IP address of my laptop here, which is an inside. So IP address is 192.168.1.15. Okay, then of course the source port. So as I told you, the source port must be something above 1024, so I can use just 1025. Okay, then the destination address. So as I told you, we'll be simulating a query to Google DNS, so the IP address of our Google DNS server is 8 8.8.8.8, okay? And of course the destination port, so for DNS the well-known port is 53, okay? Then finally we can input the keyword detailed in order to get some detailed information on each step. So this is in very short the command that we can use in order to simulate a packet going from the inside from our laptop here, which has this IP address .1.15, and going to the Google DNS server on port 53. So let's run this command and see what we get. So here you can see the different stages or steps. So we have phase 1, phase 2, and each phase we get a result if the packet is allowed or not. So here, for example, for phase 1 the packet is allowed, for phase 2 the packet is allowed, also for the NAT the packet is allowed, okay? And here we have a total of 9 or actually 10 steps, but the final result is here at the end. So the packet here, as you can see, is allowed. So using this simulation we can confirm that any host on the inside can actually query the Google DNS server, okay? So you can see how easy it is. You can perform that in order to troubleshoot your actually connection problems, okay? So let's do the same, but this time I want to reverse. Let's say that actually a host from the outside will actually try to reach, for example, web server on the inside. So remember, on the ASA firewall by default all traffic is blocked from the outside to the inside unless there is an access list, okay? So here I don't have an access list that permit that, so normally the packet will be blocked or dropped. So let's go do that on the command line. So I will do the same command, input, but this time the packet is actually coming from the outside. So I will input here outside interface, okay, and IP address, or actually the first let's say the protocol. So let's say that the protocol is TCP, and I will provide here outside actually IP address, so 2.2.2 for example, and the actually, as I told you, the source port. So let's say something bigger, for example, you can use whatever you want. Then the destination IP address, so let's say that I want this host here which has public IP address 2.2.2 want to reach my web server which is in the inside. So I will use the same IP address of my laptop which has actually a web server on it, 1.15, and of course as it is web server the destination port will be 80, okay? And finally we can add the detailed keyword in order to get detailed information. So this command actually will simulate a host that trying to reach web server on the inside, okay, and the packet is coming from the outside, okay? So let's say what we get now, okay? So we have the different phases here, but remember I don't have an access list that permit that, and you can see that here in this phase 5 the result is dropped. So our packet is actually dropped, but the final result is at the end. So you can see here drop reason, it even gives you why the packet is dropped, because it's an access list drop. So flow is denied by configured rule. So as I told you, by default all packets are dropped from the outside to the inside, okay? So you can see how easy it is. You can use this command in order to troubleshoot your networking problems. Okay, so here we have seen that using the command line, but if you have the ASDM you can also do that. So let's go to our ASDM. So here I'm using ASDM version 7.5, but that doesn't matter. So let's refresh it. So I have to provide here my password. Okay, so in order to get the packet tracer in GUI form, so you can go to the tools menu here, and you can see here there is a packet tracer menu. So you click on it and you get this beautiful window where you can simulate the same thing, but this time using the GUI. So let's repeat what we have done using the command line, but this time using our GUI. So the interface, so let's simulate that our laptop is trying to query the DNS, the Google DNS server. So the interface is the inside, so the packet is coming from the inside. It's using UDP. Okay, so here I'll provide the source IP address. So my laptop has an IP address of .1.15, and source port, as I told you, something bigger, so I'll use 1025. So the destination will be the Google DNS server, which is 8.8.8, and of course 53, which is the common port for DNS. Okay, so I have here everything. So let's start our simulation, and you can see that you can even here show the animation. So I will start it, I will send it, and here we go. You can see the different phases, so you can see an animation about our packet, and here the action, if it is allowed or dropped. So in every phase there is an action. So hopefully we'll get an allow packet here because everything is okay. So this is our inside, this is our outside interface. As you can see, the packet reached the destination, and you can see here the final result, which is the packet is allowed. Okay, so we get the same result but just using the GUI. So let's repeat for the other reverse step. So let me clear that. This time I will choose packet coming from the outside. Okay, so I will choose the packet type is TCP. I will use public IP address 2.2.2. So let's say the destination is this, doesn't matter, source port, and let's try to reach our web server on my laptop, which is .1.15, and of course the destination port is 80. So we have everything. So let's start the simulation, send, and once again you can see the different steps, and as I told you, it will be blocked because there is an access list that actually blocked that. So you can see here the result, the packet is dropped, and info flow is denied by configured rule because there is an access list that deny everything from the outside to the inside. And here in this animation you see all the process that happened and the reason why our packet has been actually dropped. So you can see how easy it is to use this very interesting tool called Packet Trace that can help you to troubleshoot actually your network problems. So otherwise, I hope it has been informative for you, and I want to thank you for viewing. Bye bye.